Hello everyone and welcome to this tutorial. I regret I can't be with you today because of a family emergency, so I send this video. So in this tutorial, this is the first question. We have to estimate the diffusivity for a carbon monoxide and a carbon dioxide system. We are given the temperature and pressure at which we wish to determine the diffusivity, and we are simply given this relationship. If we look at this relationship, you can see the pressure of the system listed, the diffusivity, so this is the thing we are trying to calculate. And then these are critical values, so this is the critical pressure or the critical partial pressure of component A. So this equation is generally for two components, A and B, so A diffusing through B. And here we've got some critical pressure of component A, then there's a critical pressure of component B. Similarly, the critical critical temperature of A and of B, and then these are of course the molar masses, and then the critical temperatures over here. And then we've got these constants A and B for non-polar gas pairs. And we also have a different A and B for pairs that contain water and a non-polar gas. So this is a fairly easy question. It shouldn't take you more than 5 minutes to do this. So please pause the video and do this now. So just looking at the solution, I'm paging further down in the problem statement. So here you'll find, together with this tutorial question set, you've got this table that gives us the Lennard-Jones potential parameters and critical properties. So we simply look up for carbon monoxide and carbon dioxide. We can read off those critical pressures and temperatures here. So those values are simply given to us with this problem set, and and so those define all these critical values. Then obviously the molar masses with carbon at 12.01 and oxygen at 16, that's grams per mole. We can estimate this factor, and then we are given the pressure. We are told this is 1.1 atmospheres, and we are also given the temperature. So in fact, this problem is very, very easy. We just have to calculate DAB. We do have to choose A and B, of course, and we can see here this system does not contain water. So this is for nonpolar gases. These are the A and B values for nonpolar gases. So we apply these values for A and B. So A and B are defined, and so then the only unknown thing left over is DAB. So we can solve for the diffusivity, and that's basically what you do for question 1. All right. Now let's go on to question 2. Let's read it first. So we are told that we have a falling water film into which oxygen gas is diffusing. And when we talk about falling films, of course, there's a film building up on some wall, and that film is falling against that wall. So bearing that in mind, we want to develop the mass balance for the absorption of the component from the gas phase into the film. And of course, the film is considered to be in the liquid phase. So the absorption of oxygen into the film, we want the mass balance that describes the oxygen concentration through the film. Then, of course, once we have the mass balance to be able to solve it, we need to specify boundary conditions. Once we have that, it's a complete set, and we can think about discretizing the equations, or we can even think about finding analytical solutions. And then once we have that, we can estimate the total transfer rate. So please, let's start off first drawing out for ourselves the physical situation. Let's draw and label the physical situation for the absorption of oxygen gas into a falling water film. So do this now. Take about 5 minutes, and let's pause the video while you do that.